Researchers have developed self-healing biodegradable 3D printed materials that could be used in the development of realistic artificial hands and other soft robotics applications. The low-cost jelly-like materials developed by researchers at the University of Cambridge can sense strain, temperature, and humidity. And unlike earlier self-healing robots, they can also partially repair themselves at room temperature. The results are reported in the journal NPG Asia Materials. Soft sensing technologies could transform robotics, tactile interfaces, and wearable devices, among other applications. However, most soft sensing technologies are indurable and consume high amounts of energy. Incorporating soft sensors into robotics allows us to get a lot more information from them, like how strain on our muscles allows our brains to get information about the state of our bodies. As part of the EU-funded ZERO project, the researchers have been working to develop soft sensing self-healing materials for robotic hands and arms. These materials can detect when they are damaged, take the necessary steps to temporarily heal themselves, and then resume work, all without the need for human interaction. Earlier versions of the self-healing robots needed to be heated in order to heal, but the Cambridge researchers are now developing materials that can heal at room temperature, which would make them more useful for real-world applications. The researcher says they started with a stretchy, gelatin-based material which is cheap, biodegradable, and biocompatible, and carried out different tests on how to incorporate sensors into the material by adding in lots of conductive components. The researchers found that printing sensors containing sodium chloride, that is salt instead of carbon ink, resulted in a material with the properties they were looking for. Since salt is soluble in the water-filled hydrogel, it provides a uniform channel for ionic conduction, that is the movement of ions. When measuring the electrical resistance of the printed materials, the researchers found that changes in strain resulted in a highly linear response, which they could use to calculate the deformations of the material. Adding salt also enabled sensing of stretches of more than 3 times the sensor's original length, so that the material can be incorporated into flexible and stretchable robotic devices. The self-healing materials are cheap and easy to make, either by 3D printing or casting. They are preferable to many existing alternatives since they show long-term strength and stability without drying out, and they are made entirely from widely available food-safe materials. The self-healing hydrogels bond well with a range of different materials, meaning they can easily be incorporated with other types of robotics. For example, much of the research in the Bio-Inspired Robotics Laboratory, where the researchers are based, is focused on the development of artificial hands. Although this material is a proof of concept, if developed further, it could be incorporated into artificial skins and custom-made wearable and biodegradable sensors.